Thank you for purchasing HT Instruments PVCHECK. PVCHECK is the all-in-one solution for measuring new installations and ongoing maintenance of PV fields. This is the first of videos aimed at making it easy to configure the instrument and get ready for use so that you don't waste time out in the field. And this is how it will look when you first start it up after taking it out of its box. So first you'll see this is the landing page. This is when you power up, the way you'll always see it, the menus. The first four are tests that we do with the PVCHECK. So you see the first one is called IV check. This is the test you'll be doing most of the time. It tests open circuit voltage, short circuit current, and this is the one that really tests to the standards. Next we have a continuity tester. This is a standalone continuity tester labeled low ohms. Next down is the insulation tester, and this is for testing the insulation, the PV, and we'll show during a different segment how much better the PVCHECK can do that than traditional insulation testers. Efficiency is where we use a clamp and also the voltage out to figure what the power of your string is creating. Setup is where the next video is going to go, as to how you set up the instrument to be able to be used. Database, of course, is how we store in the instrument the specifications of the panels you'll be looking at. Finally, memory, of course, we have to store the information and then take it out when we get back to the office. And PC is just the connection. So we primarily use an RS-232 connection, and that's where our software connects to the PVCHECK. In the bottom, you'll see the human interface is pretty simplified. It's well documented in our manual. Enter acts as the kind of like a mouse getting you around the menu structure. Save is very important. If you change anything about the setup, you must save it or it'll be forgotten. The stop go is simply when you're ready to take the test. This is how you initiate it, and this is how you would stop the test should you want to. Help is online and also provides a background light if needed, and then escape and menu will get you back to that original place with which you started when you powered on. That's about it. Oh, and of course the red one is how you power on and off the product. So go down to the set menu, press enter, tell you when to go there. And you can see these are the different categories we're going to be setting up. The first one is general. So when I press enter, you'll see very standard ideas about what language to use. Do you want auto power on or off? It's pretty self-evident. Just set it up however you prefer. If we go back, you can see that if you don't put save, it doesn't save what you've done. The next is measurement units. Now this one can be a little tricky. This is really setting up, you can see right now it's saying for the parameters of the PV panels, it sets it up as a % of degrees C, or in some cases it will actually be in milliamps per degree. So depending on the specs that you have on your panels, this is where you would set it up for the entire instrument. So if we go back, again, we're not saving. Next is date and time. This is pretty basic. You get to decide whether you want European or American style, but this is the way you set that. It comes from the factory, as you can see, the year 2000, I believe. So if we go back to the main menu. Next is this remote, and in this case I want to, this will be on another video because this is quite very important and quite sophisticated. Okay, we're continuing on with the setup of the PVCHECK. So we're going to get into the setup menu. We're going to go down to where we left off on remote unit. The remote unit is referring to our accessory called the Solar O2, which allows you to take luminosity, solar energy measurements, and temperature measurements from as far away as you need to be from the unit. But in this case, many people do not use it, and it's not a standard feature, so we're just going to say no and really go to the important part, which is placing the calibration factors in for our reference cell. Now, the reference cell is not needed to do the test according to the standards, but many customers use it in order to be able to accurately determine, are the panel, is the field, are the strings making the appropriate amount of power. So we're going to say IV check, and here is the important part. This is sensitivity. So this is a calibrated number with which determines, based on the amount of solar energy hitting our reference cell, how many millivolts are coming out. This allows the instrument to know exactly how much solar energy is hitting, and then we can use that to figure out if we're making the specification or not. On this, on the back of our reference cell is where you will see these cal factors, and this is where you put them on by going up or down with the keys. Also, there's an alpha, like there are with the solar panels, to determine any changes in the voltage out. Both of these are on the back of the reference cell, and this must be put in there because it's always set to 30 coming out of the factory. I've seen many lately that are like 26 is the calibrated number. So if you do not do this, you can get up to a 10–15% error in how much solar energy. So this is a very important one. It's one of the ones you really don't want to miss if you're using the reference cell. Okay, we're going to finish the setup now. So we're going to get back to the setup menu. We've done all these top ones. Now we're going to look at irradiance. So what this menu is really about is, depending on which test you're doing, efficiency or IV check, do you want to have any minimum amount of solar energy in watts per meter squared that would render the measurement null and void, that you don't want to see it? So if you set it for 600 and you're only getting 550 out, it will tell you you don't have enough solar energy. If you see that message as an error message, this is the setting that caused it. So you have to be very clear if you want that, to make sure all the users know that. Next, we're going to go to the final one, which is simply for the DC clamp. This is how we measure power. And it's really just a calibrated number of, and it's on the back of clamps. And ours are typically set to 1, but there may be other ones. So just in case, you have to make sure that if you're using the clamp, that it's calibrated correctly. And that's really it for the basic setup. Now we're going to move on to the modules. Thanks. Bye-bye. So the final setup is in DB, which stands for database. The PVCHECK can store up to 30 panels specifics in it for when you go to the field. Of the tens of thousands of panels that are out there, we can store 30 so that, you know, before you go out to the field, you can download them or set them up. But this is how it's done. So you press the database, and you can see here, this is just a default parameter, but these are all the specs that you'll be using in your own panels. So it's power, VOC, the VMPP, all the specifications the manufacturer gives are put into the instrument, so that if you're using the reference cell and measuring luminosity, and this will determine how well you're meeting the standard test conditions from the environment that you're making the measurement. So we will show next how you can easily download this data from the PC and our TopView software. We're back in the main screen for uploading the information about PV panels, and here's the panel that I defined earlier. So I'm just going to click on that and say yes, put it in this holding cell. There it is. And then I'm just going to say, well, send it to the PVCHECK. We're going to send it. So now these two, default and the one I defined, are in the PVCHECK, ready to be used in your measurements. Okay, so we took the TopView software, we downloaded 2 definitions of panels, the default one and also the one that we defined, and we're just going to check, make sure that it's there. So we're going to go down to the database menu, press go, and you'll see right here it's that the one that we defined is the first one up, and if you scroll, you'll see that we also have the default. So indeed, the software sent it to the PVCHECK, and here it is, all ready to go when you get to the field to make your test. And that's as easy as it is. It just, the TopView software really makes it easy to put in all the PV panel definitions you will need in any day, week, or month. And it makes it a whole lot easier to do it that way than to try and do it by pressing buttons on the instrument. So use TopView, that's what it's there for. Thanks very much. We're going to continue on with the setting up of the instrument for doing your testing. This one we're going to focus on the setting up panels inside the PVCHECK, so you would have all of the manufacturer specification. In an earlier video you saw where you can actually put these in by hand through the PVCHECK, but it's a little well, time consuming, and you'd rather not do it like that. So our TopView software is standard with all computer connected instruments from HT, comes free of charge, and really acts as the key way we communicate to our instruments. So you can see already that we have a USB cable connected through an optical link to the PVCHECK. We also currently have the software TopView running. So we're just going to connect it to and start there. So you click this PC connection, and what you'll see first comes out is a list of all of our instruments that we support this way, and telling us to select what instrument. Basically you're asking what instrument are we looking for. So in this case it's PVCHECK. We're going to scroll down, and here it is. Now you have multiple ways to do this. I prefer, because sometimes I don't know which COM port it's on, to press auto set. Auto set will look through all of the comms port and to try and find a connection. So let's see if it finds it. Yes, we're set up, and so let's see where it goes. It's working. Again, this takes a little longer than other ways. If you know the port, it'll be much faster, but it's going through multiple ports in order to figure out how to connect to the PVCHECK. So you see here that it found our PVCHECK, and it asks us a question: do we want to add it? And of course you do. So we click that, and you'll see the PVCHECK now is here. This is the instrument, this is the serial number. So we're talking right now between the computer and TopView and PVCHECK. We'll come back with how we set up a PV panel. Thanks.